Welcome back guys, and in this tutorial we're going to be looking at lines and circles. Specifically, we're looking at the difference between a chord and a tangent and how to find the point of intersection of a chord or a tangent. A tangent we've spent a lot of time looking over, which we know is a line that intersects a circle at one point and that is perpendicular to the radius of the circle. Okay? A chord, on the other hand, is a line that goes through the circle at 2 points like this and cuts the circle to form what's called a segment. Okay, so it's a line that goes from one side of the circle to the other but not through the center, which we've also looked at before because we know that one of our theorems is that the perpendicular bisector of a chord goes through the center of the circle. Okay? But today what we're going to be focusing on is how to find the point of intersection between a line, whether it's a tangent or a chord, and a circle. Now you may notice, as it says in our bubble here, that in example 1 it says find the points of intersection of the line x squared plus y squared minus 1 and the circle x squared plus y squared plus 2x plus 8y minus 8 equals 0. Well, one equation here is linear and one contains quadratic powers, which means we're actually going to follow the same steps we learned in algebra between solving simultaneous equations where one is linear and one is quadratic. So step 1 is we're going to rearrange the linear to isolate one of the variables. So we're rearranging the linear. So if I look here, I have x plus 2y minus 1 is equal to 0. Well, the easiest one to get by itself is x. So I'm going to bring everything to the other side. So I have x is equal to minus 2y plus 1. Now that I have one of the variables isolated, step 2 is we're going to sub into, usually it's the quadratic, in this case it's the circle. So sub into the circle equation. So we have the equation x squared plus y squared plus 2x plus 8y minus 8. And anywhere I see an x, I'm now going to put in what I've isolated in the linear, which is minus 2y plus 1. So that means I'm going to have minus 2y plus 1 plus to be squared plus y squared plus 2 by minus 2y plus 1 plus 8y minus 8 is equal to 0. And from here, guys, we either multiplied out our brackets or we use the perfect square formula. If we use the perfect square formula, what we see here is we get 4y squared minus 4y plus 1 plus y squared. Here we're going to have 2 by minus 2y gives me minus 4y. Okay, so minus 4y plus 2 plus 8y minus 8 is equal to 0. So now I'm going to group them together. 4y squared plus y squared gives me 5y squared. Minus 4y minus 4y gives me minus 8y. Plus 8y means they're actually all going to cancel. Then I have 1 plus 2 is 3. Minus 8 gives me minus 5 is equal to 0. So to simplify this now, I can see all terms can be divided by 5. So I get y squared minus 1 is equal to 0. Okay, so now y squared minus 1 is equal to 0. But remember, it said points. So I need to make sure I have two solutions here. So I'm going to use difference of two squares to factorize these, where I get y in each bracket and a plus 1 and a minus 1. Because again, I'm using difference of two squares to factorize here, which means my first solution is y minus 1 is equal to 0, which means y is equal to plus 1, and y plus 1 is equal to 0, so we have y is equal to minus 1. So now we can move on to step 3. Now that I have y, to find my other coordinate, I need to find x. So step 3 is we're going to find the second variable, we're going to find x. Now remember from step 1, we've said that x is equal to 2y, x is equal to minus 2y plus 1. So the first time I'm going to do this, I'm going to sub in y is equal to plus 1. The second time I'm going to sub in y is equal to minus 1. So that means I get x is equal to minus 2 by 1 plus 1. So I get minus 2 plus 1, which is minus 1. So my first point of intersection is going to be minus 1 and 1. The second point of intersection is when x is going to be equal to minus 2 by minus 1 plus 1, which is going to give me 2 plus 1, which gives me 3. So my second point of intersection, showing that it's a chord, not a tangent, is going to be 3 and minus 1. Okay? So what I want you to do, guys, is pause the video here. Make sure that we go over the steps as we add example 1 into our notes booklet, and then we're going to look at example 2. Now example 2 is the exact same here, where it says find the point, but it has points in brackets, so we don't know whether it's going to be 1 point of intersection or 2, of the line 2x minus y plus 8 is equal to 0, and the circle x squared plus y squared plus 4x plus 2y equals 0, and hence show that the line is a tangent to the circle. So again, I'm going to go through the same steps. So remember, step 1 was to isolate one of the variables in the linear equation. So we have 2x minus y plus 8 is equal to 0. If I bring my y across, I get 2x plus 8 is equal to y. So now one of my variables is fully isolated. So now I'm going to sub it into my equation of the circle. We have x squared plus y squared plus 4x plus 2y is equal to 0. And this time we're subbing in instead of y. So we're going to have x squared plus 2x plus 8 to be squared plus 4x plus 2 by 2x plus 8 equals 0. So we have x squared. Again, I'm going to use the perfect square formula here, but you can multiply it out using your brackets, where you have 4x squared plus 32x plus 64 plus 4x plus 16 is equal to 0. So now I see I have 5x squared. We have 32x plus 4x, which means we have 40x. So we have 5x squared plus 40x. We have 64 plus 16, which gives me plus 80, which means I can see here that my quadratic can be simplified by dividing everything by 5. So when I divide by 5 here, I get x squared plus 8x plus 16 is equal to 0. Okay? Which means now we're looking at the factors of 16, which I can see are 4 and 4. Okay? So we have 4 and we have 4. Both are going to be plus, which means in this case we're actually only going to have 1 point of intersection, which is that x is equal to minus 4. For step 3 now, I need to go back and find y. We said that y is equal to 2x plus 8. So instead of x now, I'm going to sub in minus 4. So I have 2 by minus 4 plus 8, which means I have minus 8 plus 8, which gives me 0. So that means my point of intersection between the line and the circle is minus 4 and 0. And since there's only 1 point of intersection, we know that the line is a tangent. But to prove that the line is a tangent, we need to show that the radius is the perpendicular distance. And to do that, I need to find the center and the radius of this circle. So we have x squared plus y squared plus 4x plus 2y is equal to 0. I'm going to use my general formula here, which is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0, which shows me that 2gx is going to be equal to 4x. My x's cancel on both sides. Divide both sides by 2, so g is equal to 2. 2fy is going to equal to 2y. My y's cancel on both sides. Divide both sides by 2, so f is equal to 1, and c is going to be 0. Which means when my center is minus g minus f, remember page 19 in your log tables, my center is going to be minus 2 minus 1, and my radius is going to be the square root of g squared plus f squared minus c. So we get the square root of 2 squared plus 1 squared minus 0, which gives me the square root of 5 units. So now if I want to prove that it's a tangent, I'm going to find the distance between my center, which is minus 2 minus 1, and my point of intersection between the line and the circle, which is minus 4 and 0. And this should be equal to my radius if it is a tangent. So I'm going to use my distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. And remember guys, we're trying to prove that it's the same as the radius, so we're aiming to get square root of 5 at the end. So I'm going to have minus 4 minus minus 2 squared plus 0 minus minus 1 squared, which gives me the square root of minus 2 squared plus 1 squared, which gives me the square root of 5 units. So now, because it says hence show, we have to remember to finish with a conclusion. Therefore, the line is a tangent because it intersects the circle at one point and is perpendicular to the radius. Okay, so we're basically defining what a tangent is. Alrighty, so take a second there guys, we're going to pause the video here, we're going to add example 2 into our notes copy, and then we're going to try a few questions. Thanks everyone, keep up the good work.